In this example, we'll take the derivative with respect to x of g of x is equal to the cube root of x. Along the way, we'll have to remember this formula for factoring the difference of two cubes, that a to the third minus b to the third is a minus b times the quantity a squared plus ab plus b squared. Okay, so remember, according to the definition, g prime of x, the derivative of g, evaluated at x, is the limit as h goes to 0 of g of x plus h minus g of x, that's the change in y, divided by h, which is the change in x. And we take the limit as h approaches 0 to get the instantaneous rate of change. Well, this is going to be the limit as h approaches 0 of the cube root of x plus h, g of x with the x replaced by x plus h, minus g of x, which is just the cube root of x, and it's all divided by h. Okay, now to simplify this, I'm going to need to get rid of these radicals, so I'm going to have to cube this thing somehow and cube this. I can't just raise the whole thing to the third power because we get extra terms. But if I think of this in terms of this factoring formula, where a is the cube root of x plus h, minus b is the cube root of x, and then I multiply this by this expression with the appropriate replacements of a and b, I'll get a cubed, or the cube root of x plus h cubed, minus b cubed, or the cube root of x cubed. So I'll basically have removed those radicals. So let's see, I'm going to have to multiply it by this other expression. Let's see, what will that be? Well, I have a squared. That's going to be the cube root of x plus h squared. All right, plus a times b. Well, a is the cube root of x plus h times b. b is the cube root of x, plus plus b squared. B is the cube root of x, so I'll have the cube root of x squared. And this will all be over itself. I'll make a copy, I think, to do that, so I don't have to write it out again. Okay. All right. Now then, in the numerator, when I multiply that out, we'll see, and you can multiply it out yourself if you'd like, we'll get this expression raised to the third will simply be x plus h, minus this expression raised to the third, which will simply be x. And this will all be over h times this expression. Okay, now of course the x's subtract off here, and I'm simply left with, excuse me, with the limit as h approaches 0 of h over h times this expression. Okay. Well, now the h's cancel, and I'm left with 1 over this expression. And provided x is not 0, the limit of this as h approaches 0 is going to be 1 over, well, as h goes to 0, this will just become the cube root of x squared. All right, and then as h goes to 0, this will be a cube root of x times a cube root of x again. So we'll have another cube root of x squared, plus we have a cube root of x squared in the last term. And so this will be 1 over 3 times, I have 3 of these, and the cube root of x squared, the cube root of x squared is x to the 2/3. So it's going to be 1 over 3 times x to the 2/3. Okay, we have a graph of this function and of the derivative here. So we have here in this graph, all right, this is, this is g of x is equal to the cube root of x, and this is g prime of x is equal to the 1 over 3 times x to the 2/3. Okay. Notice, all right, notice again, as way out here on the left and on the right, all right, notice the tangent line is sloped positively, but it's fairly gentle slope, and the derivative value is a positive value, but not very big. Same thing out here, it's gently sloping, all right, but a positive slope. The derivative value is a smaller positive number. As we get in towards the center, notice the slope, still positive, gets bigger and bigger. All right, the slope gets bigger and bigger. And if we come towards the y-axis from the right-hand side, again, the slope is positive, but bigger and bigger. We can see a bigger and bigger slope. Right at zero, if you looked at this, the tangent line would be a vertical line. Tangent line would be a vertical line. Of course, vertical lines have an undefined slope. So notice that the derivative is undefined at 0, and we can see that from the formula. If you replace the x with 0, you'd get 1 over 0, which is undefined. All right. So notice in this case, this function does not have a derivative at x equals 0.